Well, let's have a look at question 8 of the November 2018 paper. Corrosion is a redox reaction that takes place in the presence of oxygen and water. Rusting is the corrosion of iron, leading to the formation of iron 3 ions. Remember that, iron 3 ions. So they ask us to define oxidation in terms of electron transfer. Now you will remember the mnemonic O, I, and L. And that stands for oxidation is the loss of electrons. O-I-L, oxidation is the loss of electrons. So that will give you your 2 marks. A cleaned copper rod and a cleaned iron nail are placed in a beaker containing water at 25 degrees centigrade as shown. There's the iron nail, Fe is iron, and there's the copper rod, Cu. After a while, it was observed that the iron nail was coated with rust. The copper rod showed no visible sign of corrosion. Write down the half reaction for the iron nail. Now you will remember it said iron 3 ions. So we go to our standard reduction potential table and we start looking down here for iron, Fe. Now there is one, but it's Fe2 plus. So we keep on looking, we keep on going down, 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 and there we see one for Fe3 plus. So that looks like the one we want. Fe3 plus 3 electrons goes to form Fe 0,08. Remember it said that it was a valency of 3. So let's go back to our question. See, there's the 3. And there's your Fe, and there's the Fe3 ions. So when we write down the half reaction for the iron nail, we just go and we straight copy this half reaction down. Does iron act as a reducing agent or oxidizing agent in the beaker? So we've got to compare that with that. Redox always occurs together. One of these will be oxidized, one of these will be reduced. So we go to our table. So there was one iron, we can ignore that. There's the iron that we're using. Now we've got to start looking for copper. So there's a copper, there's a copper, and there's a copper. There's 3 reactions for copper. So we look for reactions that contain metal copper. When you see there's ions, that doesn't mean that it's a metal copper. There is your copper rod or there's your copper rod. One of the 2 is going to be involved, and that's got 2 plus and that's got 1 plus. That is actually going to be the reaction that we need. So this is in fact the correct reaction here. So this is the copper that we want. Right, so let's go back to our, and this is copper at 0.34. So which is going to be the reducing agent and the oxidizing agent? So we have to see which one is on top. So we've identified our 2, and I suggest to all students that you actually write arrows which one is on top. Now the one that is on top is the one that is oxidized the most readily, and therefore is the strongest reducing agent. Iron is on top, therefore it's oxidized, wants to lose electrons. All these on the top, from the lithium at the top, that will be most readily oxidized, right down to fluorine at the bottom, that'll be least readily oxidized. The one on the top is the reducing agent, or the one that wants to be oxidized. So iron will be the reducing agent. Explain the above observation using your table. Well, we've just explained it, that the one on top is the one that is the strongest reducing agent and the one that wants to lose electrons. To prevent rusting of an underground iron pipe, the pipe is connected to a metal Q that corrodes easily. So there's your iron pipe, and there it's attached via a wire to Q. This is almost like a cell. There's your 2 metals, there's the connecting wire. Moist soil is your salt bridge, so we've got a complete circle circular reaction it goes by. Now, which of these is going to lose electrons? You're given two metals, zinc and copper, to use as metal Q. Which metal would be more suitable? So to prevent rusting of an iron pipe, this is the one we don't want to be oxidized. This is the one we want to be oxidized. That means this is the one that must be on top of iron on the table with lithium on top. So this Q must be something that's on top, because the one on top is going to be the one that rusts, loses electrons, is oxidized. This is going to be reduced. When it's reduced, it doesn't change from being a metal. So let's go back to our table. That's to give the reason. And let's find, is it zinc or copper which is on top? So again, we go on the hunt and look, there is zinc. And see, it's far above our iron. So there's zinc, and sorry, we're looking for the coppers. So now there's our copper. Let's go back to the question. We could use zinc or copper. Do you see how they tell us it's 2+? Sorry, well, there in the next question they show copper 2+. So we need zinc or copper. Which of those is on top? And we see that zinc is definitely on top. So that is the one that's going to most readily go from zinc metal. You see that's negative. If you reverse the reaction, it becomes spontaneous. That also becomes positive. Zinc wants to go in the reverse direction to become positive, and then zinc will go to form zinc ions and 2 electrons. It'll be oxidized. It'll be a strong reducing agent, and therefore it'll spare our iron. But copper would not do that because it is lower down the table. So this is going to be like a sacrificial anode, such as you find in the geysers of bathrooms. It will sacrifice itself. It will be oxidized to spare the iron geyser, or in this case, the iron pipe, from decay. So there's our zinc. So we would choose zinc. We would give the reason. Zinc is a greater reducing agent. That means it's more readily oxidized than iron, and therefore we would choose that as our metal Q. If we go to the memo, there they give the answers: loss of electrons, 2 marks. Here they give the correct reaction. We say that the iron was the reducing agent. Iron is a stronger reducing agent than copper. Right, we've seen all that. And here comes to our answer. Zinc was the one because it is a stronger reducing agent, or it's higher up on that table. Don't say higher up on the table, because there's 2 tables and they don't know which one you're using. So always say it's the stronger reducing agent than the iron. Or you could say copper is a weaker reducing agent than the iron. That's another possible answer.